This is something we worked on earlier in the year, so this will be a little bit of review. Hopefully it will come back to you. So we start out with iron 2+, and iron 2+ is oxidized to iron 3+. So we're just told that in the instructions. We add an electron to balance the charge so that we get the same charge, in this case 2+, on both sides of the equation. Next, we will take the MnO4-, which is the oxidizing agent, and this you actually wouldn't be expected to have memorized, but MnO4- is reduced to Mn2+. So the next step is to balance the atoms, and we balance the atoms first of all by adding water. So because we need 4 oxygens, we're going to use 4 H2O. And then we're told that the reaction is in acidic solution, so we can add 8H+ on the left side of the equation. So now we have all of the atoms balanced, we just need to get the charge balance. So on the right side we have a 2+, so over here we have 2+, and then on this side we have 8 H+'s, and then we have a minus, so that's going to give us a total of 7 pluses, and then we want to bring that down to the same amount that we have over on the other side. Okay, at this point we have the 2 half reactions balanced independently, and we want to balance the transfer of electrons from one half reaction to the other. So because on this side we have 5, or in this half reaction we have 5, and in this half reaction we just have 1, then what we want to do is multiply this reaction by 5. Now we can add everything together and we'll cancel out what is common from one side to the other. Alright, so we have first of all 5Fe2+, and we have 8H+, we have MnO4-, then on the other side we have 5Fe3+, and we have Mn2+ plus 4H2O. So if we check, everything should be balanced. So let's do that. Let's check the oxygen. So we have 4 oxygens on this side, and we have 4 on this side. We have 8 hydrogens on the left side, and we have 8 hydrogens on the right side, and we can see that everything else is balanced. In terms of the charge, we have 5 times 3, which is 15, plus 2, so that's a total of 17 on the right side. On the left side, we have 10 plus another 8, so that's 18, and then minus 1. So that gives us the overall equation that we were looking for. So let's just finish up and mention the terminology. So what we would say is that the iron is being oxidized by the permanganate ion, that's the MnO4. So the permanganate ion is the oxidizing agent, and the iron is being oxidized, as we said, so you can also think of the iron 2+ as being the reducing agent. Okay, here's another one. This is also in acidic solution. This time we have oxalic acid, and it's being oxidized again by the permanganate. So we can deal with the permanganate first, since we just did that a second ago. So this is the same sort of reaction. So we have MnO4- going to Mn2+ plus 4H2O, and on this side we're going to have 8H+, and in order to get the electrons balanced, just like before, we're going to do that. Okay, for the other part of the equation, we've got the oxalic acid, and that's going to CO2. So we first get the atoms balanced, just like we did before, so we're going to put a 2 there, and then we're going to balance the hydrogens by putting 2H+ on this side. Then to get the charge balanced, we're going to put 2 electrons. Okay, so now we have the two balanced half reactions. In the top reaction, we have 5 electrons, so we're going to multiply this one by 2, and then we're going to need to multiply this one by 5. And then we do just like what we did before, we add everything else up and cancel out. So I'll leave the electrons out. So we have 16H plus 2MnO4 minus, and we have 5H2C2O4, and we have 2Mn2 plus, and we have 8H2O, we have 10 CO2, and we have 10H plus. So we have 10H plus on this side, and we have 16 on this side, so we can just make this 6H plus. And I think if you go through and check it, you'll see that that in fact works.